All right, so here we are with part 2 of the 8-8 analyzing decisions notes because my son woke up as I was recording. All right, he is doing fine now. We just needed to sing a few songs and all hands. All right, so here we go. Using expected value in real world situations. So apparently, Sam is climbing a mountain. Sounds exciting. 2 hours it takes him to climb the southern route of the mountain, unless, of course, there's ice. And then it's 4 hours. Yikes. It takes him 2.5 hours to climb the eastern route, unless there's ice, and then it's 3 hours. So apparently, maybe less steep. I don't know. If the chance of ice is 20% on the southern route and 40% on the eastern route, which route should Sam take if he plans to finish the climb as soon as possible? So, the idea in this is that we are going to use expected values, so we'll end up multiplying some probabilities by each of these outcomes that might happen. Okay, so it'll help if we make kind of a table to talk about what's happening here. So we've got a southern route. And in normal conditions, it's going to take 2 hours. But in icy conditions, it's going to take 4 hours. And the percentage likelihood or the probability of it having a, let's see, it takes in, if the chance of 20% on the southern route of ice. So that means 20% here and 80% here. Okay, so here's kind of our chart of what we are talking about, at least for the southern route. Okay, then for the eastern route, all right, it turns out in normal conditions, it's going to take him 2.5 hours, but in icy conditions, it takes him 3 hours. And this is the time. All right, then we have the percent or the probability. And let's see, it says ice for the eastern route is 40%. And so 60% is left over for the normal conditions. All right. So if we are going to figure out each of these, the estimated value of the southern route is going to be the 2 hours that it takes times the 80% chance likelihood, which is 0.80, and that's going to be added to the 4 hours it might take, and that percentage of likelihood is 0.20 or 20%. So the estimated value of always taking the southern route, no matter what's happening, is 2.4 hours. All right. However, the estimated value of the southern route is going to be 2.5 hours times 60% of the normal likelihood, and we'll add that to 3 hours. That comes at 40% or 0.40. And so your your southern, not southern. I already did E, so I wrote S instead. Here we go. Of eastern route is going to end up with 2.7 hours. So if we take the southern route, it is expected that it will take on average 2.4 hours versus an expected value of 2.7 hours in the eastern route. So if you'd rather spend 2.4 or 2.7 hours climbing, clearly if he wants to finish the climb as soon as possible, he should take the southern route. Okay, now, of course, there's going to be a lot of debate on if that's right, but of course, if it was icy, you would more likely take the eastern route, right? But the idea is that you do not know if it's going to be a normal or an icy condition. You got to tell someone before you go which way you're going. No matter what it is, you're better off going the southern route because your expected value is lower than if you took the eastern route. So there she be. The last example for some reason didn't print, so here we are with my handwriting of it, but this is our example about Michaela. Michaela is applying to 3 colleges, and she makes estimates or finds them of her chances of being accepted and estimates of her chances receiving financial aid from each. So in college A, she's 75% likely to be accepted, but only 30% to get a financial aid. College B, 65% likely to be accepted, but of course a lower expectancy here, but a higher percentage of financial aid. And College C is 70% of acceptance rate of those that have her qualities, and then 45% of financial aid likelihood. So they're going to ask us, at which college is she most likely to be both accepted and receive financial aid? So in these ones, we are going to talk about how these are related, but because once she's accepted, then she can apply for financial aid. So they are going to be multiplying. So what we're going to do is, again, these are independent events. And so independent events means that you are going to multiply the percentages. So for college A, the expected value is going to be technically 1 times 75%, but that's just 75%. And then we're going to multiply that by the probability of 0.3%. So again, you don't really need our 1 because it's not really going to change much. All right. So the expected value of college A is going to be 0.75 times 0.3. So 0.225. In college B, we have an expected value or likelihood here of 0.65 times 0.4. And so 0.65 makes 0.26. And college C, based on her estimation, she's got 0.7 to be accepted and 0.45 chance of financial aid. So 0.7 times 0.45 is 0.315. So taking a look at each of these rates, again, the more likely would be closer to 1. So in that case, college C is our choice, because she is combined more likely to get both of these than any of the other ones. Even though this one has a higher acceptance rate, it's not helpful in comparison to this 30% financial aid to talk about combining them together. So college C is her most likely choice to bet on here. All right, so that was the end of our 8.8 notes. So hopefully we are able to explain that the probability can be used to help determine if good decisions are made, use probabilities to analyze decisions and strategies. Again, the main point is that you take your probability and multiply it by the value that you would get. All right.